Hello guys and welcome to my YouTube channel. In this video I'm gonna show you how to measure the RPM of the DC motor and show it on the gauge using TouchGFX and STM32F746. For this project I'm gonna use RPM motor speed counter module with encoder, STM32F746, DC motor set with gearbox. Let's test the RPM speed counter module. You need to apply VCC to first pin, the ground to second pin, and the third pin is gonna be generate the pulse. When, let's say, an object passes through the sensor, it generates a pulse. This motor encoder has 20 grooves, so when each groove passes through it, a pulse is gonna be generated. Let me apply it to the DC motor gearbox set. The encoder is gonna be placed somewhere here, and when it turns, generates a pulse. We are going to detect each pulse as interrupt in STM32 and calculate the RPM to show it on gauge. Let's create a project in TouchGFX. I'm going to add gauge here. Make it center align. And let me change the background image as this one. And generate the code. In the generated folder, just open the STM32 CubeIDE and open this file. Open the application, user, and go to graphical user interface. Select this file. Now here we are going to define a function that's going to be called back as the refresh rate of the LCD, which in this case is 60 Hz, which means that it's going to be called back every almost 16 milliseconds. I should define it as virtual function. Let me add it here. Now let's make a very basic animation which is gonna move the needle from 0 to 100 and vice versa. Let's define a variable, let's say counter sign, and the initial value is 1. And here we are gonna read the initial value of the gauge. If we hit the start point or end point, we should change the counter sign. Okay, now I'm gonna update the value of the gauge. And now I'm gonna get the current value of the gauge and add the counter sign, which goes from 0 to 100, and then the counter sign is going to be reversed and starts from counting 99 to 0. Let's simulate this code. First compile and open the TouchGFX. They are synced, so you need to just simulate it. As you see, it goes from 0 to 100 and comes back from 100 to 0. Now we are going to count the interrupts of the encoder and assign the value to the gauge. For this purpose, you need to add a GPIO as external interrupt. I'm going to assign the G7, which shows in the header of the board as D4. Define the GPIO as external interrupt and enable the interrupt. Now save this code. Now we are going to define a variable in order to count the generated pulses. Here's the external interrupt handler. Define a variable here, let's say RPM counter, which is initially 0. And we are gonna add to the variable every interrupt has been occurred. And now we are gonna assign the variable to the gauge. As this is the refresh rate of the LCD, it's called back every 16.66 milliseconds. Now I'm gonna calculate the RPM and show it on the gauge. I'm gonna extend the variable and assign it to the gauge value. As the refresh rate is 60, when we count up to 60 here, this code means that we are gonna update the counter every 1 second. Since the RPM is round per minute, we should multiply the value by 60 and initialize the RPM counter for the next period. Let's make the connection. Connect the VCC pin of the encoder to 3.3. Ground to ground, and the digital pin of the encoder goes to D4. For the power supply of the DC motor gearbox, I'm going to use my power supply, which is a variable power supply from 1 to 12 volts. I should divide it by 20 since the encoder has 20 grooves. Let's upload it. And now let's change the limit of the gauge. You need to change the picture here as well, but since there is no ready to use picture, I'm gonna skip this step, and on the LCD it's gonna show up to 100. The actual value here would be 1000. Let's program it again. As you see now, the maximum value is 40, which the actual value is 400. Thanks for watching this video, guys. Please don't forget to like, share and comment below. Also subscribe to my YouTube channel for more videos.